Hi guys, welcome to today's tutorial. We'll be looking at the quadratic functions and parabolas and how to graph them using the graphics calculator, but also the more challenging aspects of finding the line of symmetry or the maximum and the minimum. This is probably the more challenging questions that you'll find in the HSC paper for general maths into do with our functions. Okay, so very quickly, what is a function or a parabola? Okay, well, we should have learnt this probably since about year 7 or 8, but definitely in year 10 you would have looked at the more advanced versions. So hopefully we know that a parabola is something that looks like this. Okay, a nice happy face. Now we used to look at the very basic form of y equals x squared. Okay, that's where the vertex or the turning point crossed at 0, 0. So it's nice and easy. We also probably looked at what happens when you put a +1 there. You would find that that parabola will look exactly the same, but it would cross at the point 0, 1. Okay, 0, 1. Likewise, if you put x squared minus 1, it would drop it down underneath the x-axis. So they're the very basic forms. Hopefully you also looked at the proper format or the proper general equation of a parabola, which is y equals ax squared plus bx plus c. Okay, just like you have a straight line equation is y equals mx plus b, we have the general rule for a parabola as y equals ax squared plus bx plus c. Now, for the most part, we don't need to be too bothered with that format. The only time we do need to be bothered with that format when we start talking about the line of the axis of symmetry or the maximum minimum, where we have to remember this formula, x equals minus b over 2a, and that's when it becomes important, because we need to know that the a value is in front of the x squared and the b value is in front of the x. They can give you questions later on, where they give you an equation like this, y, or the function y equals 3x plus 4x squared, okay, plus 2. And we have to realize that that's not in the right format, that you would have to put it into the format y equals, the x squared has to come first, and then the 3x, and then obviously the number there. So it is important to know that formula, obviously. Okay, so we're going to look at a particular question that we need to know some of this stuff in. We've got a ball that's being thrown into the air. The function y equals minus x squared plus 5x represents the relationship of the ball's height and time. So obviously the time that it takes to throw the ball into the air to reach its maximum point, I guess, or the pinnacle, and then fall back to the ground once. We want to graph this function, and we want to find the maximum height of the ball. Now, I won't be drawing the graph per se as an accurate drawing. Obviously that's going to be quite challenging using the software, but I'm going to use the graphics calculator to sort of help you out and show you what points that you sort of need. So with this, what we're going to look at to start off with is okay, drawing that particular graph. With the graphics calculator, okay, we know it's very, very useful. You can see it's got this function here, which is the table. Okay, it's very, very important. It's a very good function to use. So if you've got your graphics calculator, just go over to your table function, and you're able to actually put in that graph of y equals negative x squared plus 5x. You can type that in. So I know it's got y1 dot dot, that means y equals, okay, because it's got that at the top there. We just need to type in minus x squared, so I'm going to put the minus our x and squared, and then it says plus, which we've got there, our 5x. Okay, and then enter, or exe. Now that's stored in there. What we need to do is make sure that we have the table of values set up. So what I'm talking about that is, if I have my table of values here, and it'll be important later on, we will get you to do this, to actually just write it out. You have our x and a y. We want to put -2, -1, 0, 1, and 2, just like you do for pretty much all your sort of graphs that you're drawing. But so what this means to start means that the first x value that you're starting at, so we're going to type in -2, Okay, the endpoint is obviously that 2 at the end there. I'll type that in. And then the step means what it's going out by. Now with some questions you might be dealing with much bigger numbers, like going by 10, 20, 30, 40, 50, so the step would be 10, and here we're going up by 1 only, so step's 1. Okay, so let's press exit. So we've got our table set up properly, and we now want to press our table, and you can see there really nicely it gets all those values for you. So when x equals -2, y equals -14. When x is -1, y equals -16, oh sorry, -6. When x equals 0, it's 0. When it's 1, it's 4. And then we can scroll down for when it's 2, it's 6. Okay, and what you would probably find if I had 3 there, it would be 14. Because remember, we talk about it at some point, it will reflect itself at some stage. Okay, so there are our points, and that just stops us from having to put in -1 squared plus 5 times 1 equals 4, or putting in the -2 squared, which is 16, or whatever it's going to be, plus 5, and so 4, and etc. Plus all that. It just prevents that from happening. Okay. So it's a very quick way. So I would like you to write that down each time, okay, when you're drawing your graph. So what the marker can do, they can actually see the values. So for example, if you get these values wrong, you can still put it in correctly, and you can still get most of your marks. Okay, so once we've got that table, what we want to do is then we want to go ahead and graph it. And I mean, if you want to know what the graph looks like, you can actually go back to your menu and just go to graph, okay, and then draw it. Now you can see my graph has gone off the actual screen. So if that happens, remember we want to go to the virtual window and we can set it up. So we've got the x values from -6 to 6. Let's go from, let's say, -10 down to 10 for maximum. That just gives me my x-axis minimum maximums, and then our y ones, which is going to be, we'll do that -10 and 10 as well. Okay, so it just gives me a further out snapshot. Excellent. Let's see if that works a little bit better. Yeah, you can see it's come up nicely now. So we know what it's kind of sort of look like. So again, you would draw this very accurately. I'm obviously not going to. You're going to have it like that. Put all your points in. That's pretty awful, but you know what I mean. So you put in the 0, 0, you put in your -1, -6, put in -2, your -14, doing that accurately, etc. Now, that point is your 0, 0. Now, for this particular graph, on my table of values, I don't have the other what the x-axis where x is going to equal, or y is going to equal 0. Sorry, so you might want to actually trace it. As you can see here, you can actually trace and go all the way up. You can see that it goes all the way up, and then it goes all the way down. Okay, etc. So they can help that. There's all those sort of things. Now something's kind of happened to my calculator, so we'll smooth it back. Okay, so look, just putting a couple of points in there, you can generally draw it. So that answers the first question, graph the function, making sure you're putting x and y axis, etc., and label that graph as -x squared plus 5x, just as you can see on this screen part here. Okay, so for the next part of that question, it then says to find the maximum height of the ball. Now we spoke about the maximum height, okay, being, if you're looking at the graphics calculator, I'll just use this. You can see that's the point that I want to find. Now generally you can sort of sometimes using the trace value get about right. So we can see there and look at the y value, it's going to be around about 6.248. Okay, but we want to show some working out to show that exactly. So what we're going to do, we're going to use that formula that we spoke about before, the x equals -b over 2a. Now remember I said that formula allows you to find what we call the axis of symmetry. Okay, the axis of symmetry. Okay, so if you see in the screen, I can't draw on the screen, but you can see there, that's my axis of symmetry, and it gets me the x value, so where x equals there. Okay, so if I can find my x value, all I need to do is put that x value back into the formula, and it will find me what the y value is going to be. So let's have a look. We know that the formula above there is y equals -x squared plus 5x. So we know in this case it's always ax. So a equals -1, and our bx, so ax squared, so it's -1, and b equals 5. So we're going to put that into the formula. X equals negative b, which is -5, over 2 times -1. Bang that into your calculator. It will come up with -5 over -2, which equals 5 over 2, which is 2.5, or 2.5. Okay, so we're getting there. So that gives my x value is 2.5. If I want to find my y value, let's just substitute that back into the formula, minus x squared plus 5x. Okay, so minus, and we've got our 2.5, so that's our x squared plus our 5x, so again 2.5. So we're simply putting that 2.5 wherever the x's are. Okay, we're now going to put that into our calculator. You can put it into graphics mode if you want, but you don't have to, because it should be a straight calculation. And the good idea is use those brackets, put it exactly as I have it on the screen there. I always like to do it that way. So putting the x value into the brackets, and then you should get your y value to be 6.25. So y equals 6.25. So what we've actually found there, we found 2.5 and 6.25. So I'm just going to quickly wipe that off there. Okay, so I'll get a bit more room, so I apologize again. So what I've actually found now is that my x value is 2.5, my y value is 6.25. So what I've actually found, after 2.5 seconds, because remember our x-axis was our time, after 2.5 seconds it gets to its maximum height of 6.25 meters. Okay, look, this is challenging. I won't lie to you about that. It is difficult. Go into your textbook to the section on parabolas. Have a look at the maximum minimum problems, you know, and just have a go at some of these questions. Okay, so again, you can probably get away with a lot of it from your graphics calculators. You can see on my graphics at the moment using that trace mode at 6.248, so you can round it to 6.25. So you can get away with it most of the time with the graphics calculator. However, they'll be looking for those proper calculations. Now, as I said in class, you don't see this question too much, but you know, it means it could be there very soon. Again, have a go at your textbook, guys. Please let me know if you have any issues with this, or if any of this is a little bit uncertain. If you get any particular questions that you can't do, let me know, and I'll try to post these up on YouTube or Edmodo as well. Alright, hope this is sort of useful for you. Give me a bit of feedback, let me know what you think. Cheers.